I want to talk a little bit about some things that are, this is sort of not a business talk, but kind of talking about an application of observability and open source monitoring technology in a different sector. I thought I was going to be unique and special, and turns out like we've already had 2 energy talks today, and I think there's another one tomorrow. So anyway, I'm kind of sad that my thunder was stolen by Ryan and Erwin, but also happy that like I don't have to introduce some of these terms, and you all are familiar with some of the concepts. So I'm going to talk a little bit about me. My background, I started in my career about 13 years ago in industrial automation. The screenshot Ryan showed of Factory Talk, I think I was lucky. We were not a RS Logic's plant, but they're all like that. And that's like, the RS Logix has the greatest market share in the US for industrial control systems. All their interfaces look like Windows 3.1. It is literally, it's the kind of thing that I haven't looked at the statistics, but surely suicide is high in industrial control engineers. It is really bad, especially like, it used to not be as bad because all systems were kind of terrible, but as mobile platforms have just got to this point where we have this incredible standard for usability and user interfaces, and they just completely fail to live up to it. So anyway, this is the tricky remote. So I started very young, and it was an antiquated system 13 years ago, and it was sort of kind of isolated from the rest of the enterprise network. So that was like nice because I got to do what I want. It was bad because there were just no standards. And so I spent 3 years learning how to upgrade and bring things up to the standard that Ryan showed, which is still a pretty poor standard. Industrial systems tend to be vendor-driven, vertically integrated, especially when you're dealing, I was working for a Fortune 100 company. If there's not like another Fortune 100 company behind the product, they don't buy it in that space because it's running critical systems. It's important. There's reasons for that, but there's also like ways to get around it for things like metrics and dashboarding and those sorts of things that you all are building every day. And integrated is used very loosely in that space for sure. So it was actually, in my case, I had 67 separate vertically integrated architectures. We kind of commonly know those as silos now. So anyway, I learned a lot. Maybe, not the best way to do things, I learned. But anyway, so why am I here? I'm going to talk about a project I've been working with the City of Washington, D.C. for the last 18 months. I'm going to start by introducing sort of a cast of characters. So DGS, this is the District of Columbia Department of General Services. They manage all the infrastructure, facilities for the City of D.C. And DGS Facts, which you can sign up for like Cat Facts. This is about 28 million square foot of real estate portfolio, estimated value of around $40 billion. They spend almost $500 million a year just on energy, on operating, and then $100 million a year spent on energy. DC is a great city. I would say it kind of competes at a global level for sustainability and kind of pushing progressive civic initiatives. So they started in 2012 they established a specific division just for addressing sustainability and energy. And in general, their city government is very progressive. They have a zero carbon goal for, I don't remember the exact date, but anyway. So, and then the next character in this cast is NCE. So NCE is a consultant that works with DGS to help provide and solve those problems that address these sustainability issues in the Energy Sustainability Environment Division. NCE's kind of first big thing they did was build Smart DC. So this is something that got international recognition as a platform for energy. The process covers sort of this like establishing some design standards for buildings and what systems should look like to achieve sustainable, efficient systems, and then monitoring those to ensure you're actually delivering on those goals. And then the systems that you have that are not meeting those goals, retro-commissioning. So I'll talk about that a little bit more later. So Build Smart DC was launched in the summer of 2013. It's a publicly accessible portal that aggregates the energy consumption data for the entire DC municipal building portfolio for anyone to see. So not only was it sort of groundbreaking in that it was the only time a city had ever pulled that data, and in fact it was for the utility they were working with, it was the first time anyone had integrated with their 15-minute interval data, because utilities in the U.S., if you're in an investor-owned utility situation, IOU, they don't tend to share the data like you would hope. So anyway, it was a technical feat that they aggregated all this data, but there's this real policy thing there and process thing. By putting that data in the public view, it established sort of a responsibility to the public from the DC government to address those buildings that were using some 4 times the national average for energy per square foot, those sorts of things. So it really provided a political cover for spending money on sustainability and efficiency. And it was near real time. So I think every day and near real time for you guys is different from energy and obviously, and definitely different from me as like an industrial guy. I've been pushing higher and higher resolution metrics ever since I got involved in this project. But every day they would get the last 15-minute interval data for the last 24 hours and aggregate it and then present it in this portal. Skip. So next character in this cast is Voltron. So I have to hold it just right. This is a US DOE sponsored open source platform for what they call transactional energy. And so they envision this future where every time a device needs energy for something, Irwin's washing machine being an example, it negotiates with the other devices in your house, and your house may negotiate with the other houses in your neighborhood to establish where that energy should come from. Why, how does it give you the best cost for the energy that's possible? How does it have the least environmental impact? You can build your market that makes these decisions around whatever metrics you want. But you need a platform to do that, and it's in an industry that has very little integration across companies or anything. So they felt they needed to build something. So it's essentially a framework for distributed sensing and control, and it has some sort of sane, that's sane. We'll leave it at sane. Sane security and trust defaults that allow you to build trusted distributed systems that can communicate with each other and negotiate these transactions or move data around or any of the other sort of simpler use cases you can imagine. Keep in mind, and the guy that spoke about CERN may know a little bit about this, but it was a system built by researchers for researchers. They wanted to see commercial adoption, but it was definitely like a thing. When I got involved, it took a lot of work to get it where it is now. So I'll tell you a little bit about what we're doing and what we've been doing for the last 18 months since I've been involved. So really focusing on empowering this retro-commissioning by going beyond this energy level data of a building and into what is each piece of equipment in the building doing. And a little definition here. So what is retro-commissioning? It's really just about going in and figuring out what should this system be doing, what's the difference in what it should be doing and what it is doing, and how do we restore it to what it should be doing. And kind of focus on this intent, because intent is not state, right? So even sometimes buildings that are brand new, the designers who design them do not have nearly as much input as would be optimal into how they're actually operated from day one. And these systems are complex at this point. They do look a lot like industrial processes. You have sort of these central plants generating one product stream. The room conditioners are consuming one or multiple of those product streams. The end user just is like, am I comfortable or not? But there's a lot of complexity that goes into that. And it's, it changes constantly as all of you come into this room. The heat load, if there was an air conditioning system here, goes way up, and of course you have to respond to that. And then when everybody walks out into the atrium, all that load that was going into systems cooling this room now has to cool all that stuff changes dynamically. So when you optimize, your optimizations need to be able to be responsive to all those sorts of changes. And this is great. The focus on energy efficiency for mechanical engineers designing these systems has driven some really incredible innovations over the last few decades. But they keep getting more and more complex. And if you don't have that sort of continuous path into the facilities operators, all that complexity suddenly, you've designed something at one efficiency level, the actual achieved is half that. And it's because there is this sort of mismatch between what the design intent was and what actually got built, which may be different, and then how it's being operated, which might be different still. And there's some parallels here to technology. I don't know if you're picking that up yet or not, but it's definitely there. And these system designers almost never connect with the folks who actually end up running these systems. I could just throw the DevOps brick wall up here, and it's completely applicable. It's the exact same scenario. So, and this complexity, this building systems are also another sort of vertically integrated, vendor-driven industry. And the complexity, rather than sort of embracing it and say, okay, these systems are complex, the people operating them need to understand some of the complexity. They need to be able to look deeper and find out why, when they're adjusting a thermostat, something's not happening or something is happening, how this room, affects the ability to condition this, all those sorts of things. It's like, oh no, we're just going to build a product and then we tell you it's going to be fine. And eventually all that just sort of, it turns into basically technical debt. And now instead of having a system that you can't run or don't know how to run, now you have a system that you don't know how to run, and a system that the value-added integrator doesn't know how to run, and a system that the consultant to the value-added integrators doesn't know how to run. So anyway, it just keeps kind of layering up. So our goals with what we're trying to do with the portfolio, the built environment portfolio for the City of D.C., is define the metrics, because what you measure is what's going to drive behavior, right? So same thing with the original Build Smart goal of surfacing this energy usage data so that there was political pressure to address these buildings that were consuming, ridiculous amounts of energy. Those metrics are what define what your behavior is. This is also this could be a DevOps talk right now, right? This is all just the same stuff. So we obviously want to reduce energy consumption. That's important. And through reducing energy consumption, we can affect the carbon input. And you can move energy consumption around to affect the carbon footprint as well, right? You can use energy when there's plenty of wind energy available, and then use less energy. You might use more aggregate, but you can use less of coal or whatever the evil energy is in your market. We want to raise the standard for comfort, right? These complex systems that have this sort of simple end goal of providing a comfortable space and a safe space and a healthy space for people, if they're not working efficiently, they're probably not working well either. And so we want to address, not just efficiency. We're not trying to run at, the bare minimums. We want to make sure that we're, delivering the amount of oxygen people need, the CO2 levels are regulated correctly. There's a lot of research now. I don't know how many really work optimizer people we have in here, but there's a lot of research now that points to sort of a few percentage points or tenths of a percentage point variance in CO2 in a room can affect your work output dramatically. So ventilation's important. And then to keep from getting back in this problem in 10 years, we need to build processes and develop a workforce that understands the systems that they're running and understands how to continue operating them, understands what they're supposed to be doing, understands, what is this system that's, bolted on to achieve some additional efficiency or achieve some additional health benefit. What is it supposed to be doing? And when it goes off, I don't just flip the breaker off and walk away, right? You actually need to get it back. All those sort of understanding the intent behind the actual infrastructure. And then save money, right? I don't have a job, I don't get to do this stuff if we don't actually deliver an ROI, because governments are strapped for money, so it's not like they can do this just because. And we want to keep doing more stuff. So what we're doing now is sort of disaggregating energy and operational data down into, this room, may have 10 temperature zones, measuring all those temperatures, measuring the airflow, measuring the temperature of the airflow, being able to differentiate how many, watts are going into cooling that area of the room versus this area of the room, maybe understanding that, one air handler is just not doing anything in this room and we need to address that, et cetera, isn't picking up any of the load when the room is loaded. And data quality is very important in this space. So our approach is to sort of address all that at the front end, make sure we're doing the right kind of tagging. We want to be able to use this data. We want to be able to use it at multiple levels of the organization. We want the facilities guy that's on site here to be able to pull up his phone and answer questions about that can help him solve the day-to-day problems. We want the technicians who are solving deeper technical problems with the equipment to be able to dig in and troubleshoot individual points. And then we want to deliver sort of this energy cost efficiency to the executive level who are making decisions about which buildings to sell or buy or keep or whatever, that they can actually see the actual costs associated with these things. What happens when you don't practice with your slides enough. So we'll just go on to the next. And then we also want to deliver this data to the public as well, because there is this value in establishing this sort of political accountability to how these systems operate. And we think that the deeper that can be, and obviously it has to be simplified in some way the public can ingest it, but the deeper that can be to say that this air conditioner at this building is costing the city an extra $10,000 a year because some maintenance cost hasn't been appropriated, we think that will drive the right decision to get that air conditioner refurbished or repaired. And so here's where we are. This is what I felt like I couldn't do a technical talk without some sort of architecture diagram, so this is very broad. We're definitely using Grafana. We have, building equipment sort of has multiple standards. We figured out ways to sort of aggregate that into one standard, and then the IoT gateway that we're using that runs the Voltron platform interrogates using that standard, pushes the data up the message bus into a crate.io cluster that we operate in AWS, and then we're able to visualize out of crate into Grafana. We also, of course, instrument all that infrastructure. We're using Prometheus for the infrastructure, and I also, just because it's really cheap and easy, and you'll see why, because we're not dealing with massive amounts of data in comparison to sort of the types of applications you would get or metrics you would get out of application monitoring. I also shove all of our machine data into Prometheus, but only for a month retention, and then drop it out because it's really cheap, and I can play with dashboards and stuff without hitting my my crate cluster, and it's faster, but I'm the only one that uses it. So, and then of course log data out of all these systems as well, and we're using Logstash and Elasticsearch for that. Right now we're at 46 sites, so 46 buildings have our gateway and have some sort of integration pulling data in. We pull about 30,000 data points out of those buildings. We have access to about 230,000 total in those systems, but we really only trend the ones that sort of have been established as meaningful. We collect about 2.7 million samples per day, and we've built up a corpus of almost 1 billion records. And I don't let anybody on my team call that big data. It's obviously small or medium data, as I like to refer to it. I will say that we are, there is a machine learning aspect. I think we made it almost through the whole day without talking about machine learning, which was great. I really was disappointed. I thought when Raj was talking about monetization strategies for Grafana, he was going to announce an ICO, but that didn't happen either. So anyway, I'm going to show a few dashboards. Our dashboards are not beautiful, but I am really proud of these. Because I didn't build them. Actual HVAC technicians built these dashboards. So that to me, yes, they're not great. Yes, there's too much data up there. But the fact that I have non-technical users, using Grafana and doing the data discovery process is huge for me, because I think that's where the value of these systems over the vendor-driven systems really shines in this particular segment. So this just allows a technician to pick a building, pick a location or a building, and then a type of equipment, and see all the data points associated with that. So if someone's calling about a particular room, they can dig into the room level and see what's going on in that room. This is a little bit of a broader building overview. Again, way too much data, completely, the only thing useful here is to be able to see that, hey, all these are within some bounds visually, which there's a lot better ways to get that information. And this is the same kind of thing, using the heat map to show those same sorts of is it within our what bands we care about. I actually have worked on some of these, so again, a lot of data here, but just to sort of visualize how much is going on, and then we're ignoring everything that's in our healthy realm. And this is actually one of the better buildings. It's also one of the larger buildings. So 25 sounds like a terrible number of things to be in trouble state, but it's actually out of 800 or something. So, and then you get this list of all the ones that are exactly which room and all that stuff is in there. All that's work in progress stuff. But despite not having pretty dashboards, I think what really matters is that we've saved the City of D.C. $4 million to date. We're sitting at about $1 million a year in annual recurring savings on the energy side. 20% reduction at the sites that we've really focused on and established the retro commissioning processes using this data. And on track for this year to deliver an additional $500,000 a year in recurring savings. So kind of where are we going next? We want to continue to develop the business processes, right? The data doesn't really matter if you're not using it and making good decisions. So we think that really focusing on the right policies, especially at a municipal level, because we'd like to influence, this is just municipal buildings, we'd love to influence commercial portfolio owners to adopt some of these practices to reduce the carbon footprint of the city at large. We want to implement DERMS, which I'll get to in a second, and then this thing called constant commissioning, which I'll also talk about in just a second. And then I really think this is important is, how do we answer those people kind of at the front line of the facilities management and give them the tools they need? And I hope that it's Grafana. Maybe we have to build some simplified things, but eventually get them to using Grafana. But we want to be able to give them the tools they need to actually take ownership of the problem of the sustainability of a building and drive change. And then this is another one that's I got a sort of glossary for this, but integrate not just the existing mechanical systems in a building, but the PV, energy storage, et cetera, to deliver virtual power plant solutions. So what is constant commissioning, someone asked? So it's just to sort of maintain, and this is where we hope to use machine learning to help address this, but instead of just restoring it to a state and then 2 years later you come back and it's degraded again and it's using twice as much energy as it should be, using the data we're collecting to sort of find each little problem as it pops up, and while it's still addressable with the existing operations budget, before it becomes we need a whole new $1 million or $2 million mechanical system at this building. then distributed energy resource. So this is just sort of the next generation. Some would say the next generation. Some would say like this buzzword's already dead, and like no one ever really delivered what this was supposed to do. So we're going on to this next like transactional energy paradigm. But basically, the ability to deliver demand reduction across a large scale using whatever assets you have, whether it's you have electric vehicles plugged into your building, you have PV on the roof, you have storage, you have the actual mechanical systems themselves that you can shut down or slow down, et cetera, and do that across a large portfolio like I'm talking about to achieve megawatt or larger cuts in your demand. And the virtual power plant is actually taking that to the next scale, where you're doing it at not just say one portfolio, but you have merged multiple portfolios, and you're actually negating the need to build new physical infrastructure by just being able to model and control the load better. And so we really think we can get to that in DC with sort of the political climate and the not the U.S. political climate, the City of D.C. political climate that we have there. I feel like I have to say that. And the technology resources we have. And really it's about delivering this sort of what you all talk about every day as observability in this other paradigm of building systems. And we want to, as us as a group, like we want to build the platform that enables this, not just for DC, but everywhere. So that was my talk. I don't know how I did on time, probably a little fast, right? Any questions?
So you said you have plans outside of DC. What's the structure that could happen in?
So right now we're set up to do business with cities, right? Like, but I think we could really deliver that to any large real estate portfolio owner. We've got some projects now that are piloting parts of this, but not the entire integrated solution in some private commercial real estate projects.
I've got two questions, that's all right. They're very different. The first one is you're using CrateDB. What made you go with that choice as opposed to one of the other time series databases, and how have you found that? And my second question is, you talked about the 4 million savings. How has that actually come about through the platform that you built?
So it's not like delivered by the technology stack, right? It's delivered by the processes enabled by the technology stack. But that's just looking at historical energy usage versus the buildings where we've implemented the programs and the policies. And then obviously we look at it from the terms of like kilowatt hours used, but then using the market rate for power. Did you ask two questions? I didn't answer both. What was?
It was about your Crate.
Oh, yes, sorry. So how am I on time? Do I need to hurry? Okay, so I left out a bunch. I gave like a version of this talk a while back. I left out a lot of the technology path just because I figured most of the talk today would be very technology heavy, and I just want to talk about this completely different application. One of the like by researchers for researchers things, they had adopted an open source platform that was abandoned and for their historian, their data repository, and when they needed to pick a new one because this open source one had kind of it had no community, so like it was a dumb choice in the first place. It was one guy. They decided that what they really needed was to go web scale. So they were storing all this metric data in Mongo. And if that's not bad enough, they were storing one sample per document. And if that's not bad enough, there was no indexing. So I came in, I was like, all right, we definitely don't need to be using Mongo. We need to be using something else. The Build Smart platform, some of the same players that built that are still involved in the project, and they build some sort of some back-end dashboarding that's about sort of reporting on the energy usage and that sort of thing. They were using Postgres. At the time when we made this decision, there weren't all the options there are now. I mean, when I first Monitorama 2014 was my holy crap, all this exists, coming from this industrial background. There were 10 time series databases that were sort of viable. Now there's 70. So, but Crate was really about having a SQL interface that they could integrate with, the legacy code basically, and some level of horizontal scalability. And yes, I know that Crate uses Elasticsearch, and that's not actually a solution. But it's working well for our application. It handles the load we throw at it. It does some really nice, it handles the analytics load really well. And we like it pretty well. PNNL, who is our project partner on the DOE side, also deployed Crate to replace Mongo. And they've got a lot more historical data. I think they're in the 5 or 6, maybe 7 billion records. And this is different. The reason why I didn't just throw it in Prometheus is we want 100% retention, right? So that's the sort of difference between what you all are normally working with versus this stuff.